Hello, and welcome to my lap counter technical report. My name is Tyler Sheardown, and I am going to be showing you my technical report off of the lap counter device. What is a lap counter? Well, in general, a lap counter, implied in the name, is a device that a runner would use to count the number of laps that they have completed around a track. This is just a small handheld device. It's nothing too big. For this project, I am going a fair bit more complicated than that. It is not going to be something that the runner will be holding. It is something that is going to be placed on the ground, and any time that they run, it will count that lap, but also when the runner has completed the run, a little LCD display on the device will tell the total distance that they ran. It'll show the total amount of time that the runner spent running. It'll show the amount of time it took the runner to complete every individual lap. It'll show the average speed and the speed of every individual lap. Now, the only thing about this is the runner will have to input the distance of a single lap. That is not a big thing. They'll just have to say how far one lap was in kilometers. Then it's able to actually calculate the rest. It could still give you the time, the total time and the time per lap, but for stuff like the speed and the total distance, you just have to input that. So the general design, I had to basically ask myself 3 questions before I could start. How will it record, calculate, and store the information? Basically, what's the brains of the whole operation? How will it be able to know when someone's completed a lap? And how will it be able to distinguish a runner from, say, just a pedestrian walking by, or maybe a car driving by? So how it's going to be able to record the Arduino. That was the easiest decision I could have made. There was other microprocessors that could have worked, like the Raspberry Pi, but I've never programmed a Raspberry Pi before. The other devices like this, I've never programmed. I've never worked with. But Georgian College has provided about pretty well half of the Intro to Microprocessors class to programming specifically the Arduino. So it saves me so much time on having to do anything else. The second question is, how will it be able to know when a lap's completed? Well, I'm using the ultrasonic sensor. The sensor is actually a distance sensor. It sends out an ultrasonic sound, which will bounce off of the closest object in front of it and then back into the receiving portion of the sensor. And the time it takes for it to do that determines how far away the object is. So that doesn't really matter. I don't really need to know the distance, but the point is that when the device is first fired on, it'll detect that distance, it'll store that initial distance, and then if ever that distance changes dramatically, the device will sense that. And it'll say, hey, something just passed by, increment the lap counter. That is how the device works, or how the sensor is integrated into the Arduino. And then finally, how it's going to distinguish the runner from any object. How is the ultrasonic sensor supposed to know it's detecting the runner as opposed to literally anything else? Well, the runner is going to have to be equipped with a transmitter and a receiver attached to the lap counting device. And whenever the runner is within range of this lap counter, the lap counter will be like, oh, he's close by. The next one that goes by, or the next object that passes by, count that as a lap. And then whenever it's away from its range, it will say, hey, don't count anything else. Don't count anything until we know he's close by, until we can sense that transmitter. Now, unfortunately, the final device does not possess this transmitter and receiver combination. It took a very long time for the transmitter and receiver that I'd ordered to finally get here. And by the time it finally got here, and me trying to problem solve with it, I realized quickly that it can't work on its own. I had a button battery set up with it and everything, but I needed another processing device altogether. Any video online for how to integrate it involved another processor attached to the transmitter. So I would need, at the very least, a Arduino nano-sized microprocessor, which is the smallest one that Arduino makes, as well as a 9-volt battery, wires to attach all of them together, as well as the button battery, the transmitter, all of that. Now, I don't have most of those things, so that was already not in the option, but also, as far as practicality goes, To be able to tell a runner that they have to run with a small transmitter is one thing, that's fine. To be able to tell them they have to run with a processing device, a 9-volt battery, all this sort of stuff, that becomes another problem. So I couldn't do it, and it's almost impractical to do it. So in the end, I had to finally cut out this. But I just want to point out that it is possible to do it. To be able to design for this is totally doable. Now the program. So this is my program. I do not have enough time to explain this entire program. I just wanted to briefly show that this is the bulk of the entire project. The rest of the frame and all the other devices that are attached to it are relatively simple. Programming them all so they work exactly as they intended, this is where the bulk of this entire project came from. And I don't really have time to show any of it, but I just wanted to show this just to point out that though all of this may seem simple enough to do, this is where the complicated parts come in. So, the final product. So this is the lap counter final product. I have it on a small block of wood going up through a wooden shaft up to the nose of it. And right on the nose you can see I have my ultrasonic sensor. That is the front of the device. On the back of the device I have a small box. Inside the box is the Arduino, and on the front of it I have a LCD display, and I have a four push buttons to navigate the LCD display. You're going to see what that does in a minute. And right on the top I have the labels for the 4 buttons: up, down, enter, and back in order. And now it's plugged in and there is power going to, well, everything. So I'm going to try to zoom in and hope you guys can see that. Yeah, okay, you guys can see that. So if I hit the up button from here, it'll move that first digit up by 1. If I hit the down button, it'll bring it back down. If I hit the enter button, it'll take the second 0 point and let it move up 1. And if I hit down again, it'll move down again. Now I'm going to hit enter, and if you keep hitting enter, it lets you adjust every 0 on there. I'm going to put, that is not the one I meant to be on. I am going to hit enter again. And now I am here. I am going to adjust for 1 kilometer. I'm going to hit enter again. And now I'm at that final point. And if I hit enter one more time, now it says pass sensor to start. So now it is ready. It'll start the timer and start your run the moment you pass by that sensor. It won't start until then. So if I put my hand in front of the sensor, and now it says running in progress. So every single time I would put my hand in front of here, it would stop, count the lap by 1. There's also an internal part in this where once something passes by the sensor, it won't accept something passing by it again until 10 seconds after the first object passed by it. This is just so nothing would re-trigger it right after it walked by, or like the same object wouldn't trigger it twice. It's also good if I had the transmitter and receiver hooked up to it. So it'll just keep saying running in progress. It won't stop saying that. I'll keep putting my hand in front of here, and it'll keep counting that as a lap over and over and over again. So I never showed it, but I just finished moving my hand across it several times. So now if I were to push any button, it doesn't matter which button, if I were to push any button, just going to make sure you're focused in there, it gives me a little prompt that says good work. Just a happy little gesture. So right away it'll give me the total time. So the total time it took me to do all that was 1:43 seconds, and said milliseconds. Now if I go down from there, it'll show me the total distance, which is 4 kilometers. If I go down again, and this is just me pushing the buttons. So this looks funny. If it was a real test, the kilometers wouldn't look so messed up. But because I said it was 1 kilometer each, and I just kept moving my arm across it every 30 seconds, it thinks I'm way faster than I actually am, than what is possible for someone to run. But the math internally makes sense. And then total number of laps is 4. That makes sense, especially with the distance. And then lap times. If I hit enter while I'm under lap time, it says enter to view underneath that. it'll show me the time it took me to complete one lap, 22 seconds and 9 milliseconds. If I hit down, it'll show me the time it took me to do the next lap, which was 40 seconds. The third lap was 25, and then the fourth lap was 15. Now, if I went down from here, it would still give me a time, but it would just be 0, because I never completed anything over 4 laps. So this is how you can view every individual lap. The final product did have some problems that was not just showed in the little side video. The ultrasonic sensor did not work as it was intended. As I described before, the ultrasonic sensor is a distance sensor. It's not anything else. So the sensor, the way I designed it, should have still worked, but I did not take into account the amount of time it would take for the ultrasonic sensor to trip when something walks in front of it. I thought that it was going to trip instantaneously or within a very, very short amount of time, but it took so long for it to trip that if the object did not stay in front of it for long enough, it would not detect it at all. And during the testing, just having the person walk in front of the sensor, it wouldn't trip half the time. So to be able to tell the runner that, for how hard they're working to try to do a marathon or whatever, and the sensor is only counting about half of the amount of work, probably more, because this is only for walking, what I was testing for before. Running, it probably won't detect it at all. But in either way, to say that it might not work to someone who's working that hard, or you couldn't really present this to them and they'd really want this. That would be a humongous turnoff. So the final product, sad as this is to say, just not work as it was intended to. And there was not enough time for me to order another part. So the solution to this, I found another sensor that would work. It is a diffuse reflective sensor. Essentially, it's the exact same as the ultrasonic, except instead of sound, it uses light. And light moves unbelievably faster. So having someone walk by and a laser hits off them and bounces back into the receiver, it would work so much better. It works so much faster, and it should not trip. And I found one that would work. I should have considered this at the start, but unfortunately, this is what it came to. The only downside of the sensor is I'd have to change the Arduino code somewhat, and it may not detect the person if they are wearing black. So the light, instead of bouncing off them, might be absorbed into the black object. So that is still a better outcome than trying to use the ultrasonic sensor. So this would be the new sensor that have to be implemented. So what would be next? One would be to add in that sensor I just described. Another consideration would be, again, to fix up the design of the transmitter and receiver, because that would be, it might still not be practical to use it, but I'd still like to try looking up other processors that might work with it, just to see if it is doable. It might still not be, but it'd be worth it to at least look into it. Another thing, I didn't weatherproof any of it. As far as a technical report goes, everything here still works, but as far as actual practical thing to work on, weatherproofing the device would be the next step. When it came to time and what I had to put my time to, that was on the bottom of the list. I didn't even say I was going to do it, but just practically, that'd be the next step. So, to answer some of the questions, which of the previous or current courses prepared you the most for the project? Again, microprocessors. Saved me an unbelievable amount of time, and even if I was going to go learn another processor like the Raspberry Pi, that class gave me the foundation for how processors work in general. So, without a doubt, this was the best class for this. How do you see this project being used as an industrial or commercial setting? Well, it wouldn't be used in industrial, but it could be used in industrial, or it could be used in commercial. This would be more of a product that could be sold to the running community, the jogging community. To put it simply, just in the United States alone, there was about 500,000 people partaking in marathons. And that's just in the States. I don't know worldwide what it would be. But it could definitely be built and marketed as a commercial product to be sold. I'm basically like bringing this into Dragon's Den and being like, hey, fund me so I can build this project, build this device at a much larger scale. And that is my presentation on the lab counter. I hope you enjoyed it. And these are the references for my photos. Thank you.